Lesson 12, Standard Deviation. Aim. Let's investigate standard deviation, a measure of variability. 12.1, Notice and Wonder, Measuring Variability. What do you notice? What do you wonder? So take a look at these 6 distributions. They gave the MAD for each one, but again, I don't really want to talk about that measurement since we really will never see it elsewhere in your life. So take a look at these 6. I think we've seen distributions similar to them before. So if you'd like to look at the video on lesson 11, you may find that helpful. But what do you notice and what do you wonder about this standard deviation? All right, this one here has a standard deviation of 2. This one's got a standard deviation of 2.92, 2.34, 0, 1.61, 2.58. So what is affecting standard deviation? What's making it go up and down? Things that you might notice, think are true, or things that you are questioning, not sure about, things you wonder. At least 2 of each. All right. Well, hopefully you noticed that the lowest standard deviation, 0, is this distribution right here. And we've got a mean of 10. So every single value in this data set also has a mean of 10, and its standard deviation is 0. So that's really telling us that never, ever at all do any data points deviate, stray from, change from the actual value of the mean. Here we've got the next lowest one would be 1.61 here. So I'll call this 1 because it's the smallest standard deviation. The next one here, number 2, most of my values are still in the middle. Compared to all the other distributions, still most of them end up being in the middle right here. So it's going to be a little bit higher than 0, but certainly not going to be higher than the other ones. The next highest would be right here, 3. You can see this also has most of its data in the middle. It's not quite as dramatic as this one, where really you can see there's way more data in the middle than this one here. Next, we've got right here, standard deviation of 2.34, which is relatively close to 2.58. Why would this one be lower? Well, even though I do have a bimodal graph, my data is still a little bit more congested towards the middle. Here, everything is pretty equidistant from itself, from each other. So that's why that one's going to be a little bit higher. Then this one, of course, most of my data is all the way in the endpoints, far away from the middle. So that's going to have the highest standard deviation of all. So the simplest way to put it, standard deviation is a measure that shows how variable a data set is. Okay, so let me give you an example of how you actually calculate standard deviation. I'll of course show it on the calculator, but I do want to show it by hand quickly first. You will never have to do it by hand, but I would feel bad if I didn't show you, because it is kind of complicated, so don't worry, you will never have to do this, so just sort of appreciate the math behind it. All right, let's say I have a very small data set. Let's say I have a data set of 1 and 3. That is literally the only numbers in my data set, 1 and 3. So the first thing I want to do if I'm going to calculate standard deviation is I'm going to find the mean. So 1 plus 3 over 2, that's 4 over 2. So my mean, x bar, is equal to 2. So basically what standard deviation is it's averaging how far all of these values are from 2. So you can see that 1 is 1 away from 2, and 3 is also 1 away from 2. So this is going to have a standard deviation, and I'll abbreviate SD. This is going to have a standard deviation of 1, because on average, everything is 1 away from the standard deviation. Let me show you the actual math that goes behind that. So what you really do is you find the difference of every data point and the mean. So 1 minus 2 would be 1 difference. And then also 3 minus 2 would be a difference, right? 1 and 3 are the 2 points from my data set. So the difference between 1 and 2, 1 minus 2 is negative 1. Difference here is 3 minus 2, that's positive 1. However, the thing about standard deviation is it doesn't matter if you're above the mean or below the mean. You're still going to be just as far away. So they could technically, I think, use absolute value here, but the way they use it in the formula is they square both of the differences. Or if I had 3 values in my data set, I'd square all 3. If I had 100 values in my data set, I would square all 100 differences. And once I've squared them both, so negative 1 squared is 1, positive 1 squared is also 1, I add them together and divide by the number of numbers. So 1 plus 1 is 2, so that's 2 over 2. And then 2 divided by 2 is 1. Right? And the last thing we do is we take the square root of our final answer. See how I squared both of these differences? Let's say we were talking about people, right? That would mean that I square the unit people as well. So my unit would be people squared. So to get it back to my original unit, I take the square root. And the square root of 1, in this case, we only want positive numbers for standard deviation. So that's going to be a positive 1. Let me just show you what that formula looks like. It's got that summation symbol, which really just means add them all up, which is what we did right here. So we're trying to add up all of the numbers in my data set. So let's call them x sub I. That could be any number in my data set. And I'm going to find the difference between that and the mean, x bar. I'm going to square that difference, and then I'm going to add all these differences up. Divide by n, which is the number of numbers. And then finally, we take the square root of the whole thing. Very complicated formula. I hope I didn't freak anyone out too much. I want to quickly show you how easy this will be for you. So first we're going to go to Stat, then we're going to go to Edit. And so just on list 1, you see I already put it there. We're going to put 1 and 3, which are the 2 numbers we have right there. Then we're going to go to Stat again, go over to Calc, 1 bar stats, and press Enter. And then if you look here, you'll see this little weird little circle looking thing. Looks almost like a eyeball. That's called sigma. I mean, no, I'm sorry, not sigma. That's called, actually that might be a lowercase sigma. I think that's the Greek letter. I'll write it right here. It looks like that. So that's called our Greek letter for standard deviation. I think it's called sigma. I'll look it up real quick for the next video. But basically you can do all this on your calculator. I will also post a video showing you how to do it on Desmos for those of you who don't have a graphing calculator at home. All right, but really all you need to know about standard deviation, the higher it is, the more spread out my data is. The smaller standard deviation, the more compact and close together my data is. All right, that's all for 12.1.